hate black.
That's literally something on the inside.
Just causes smudge. All right, guys. So anybody got any questions about last night trig limits? Anyone?
I'm focused.
On Giffen. All right. So trig limits. Anybody got any questions on? Yes.
Can you do number 8, page 31?
Of course. Oh, 31. Going way back. Number 8. Okay, so on number 8, always first thing you do is what?
Plug it in. No. 0. No.
So I plug it in and I get 0 plus 1 is 1. And then I plug a 0 in there and I get 1 minus 0, which is 1, and I get an answer. I'm finished.
Nice.
Don't think about like if you get an answer, don't think about it. Why do you not have to think about it? Because
you just don't.
Because parabola functions are continuous. Trig functions with shifts are continuous. So the only possible place this thing has a hole or an asymptote if this sine is equal to 1. And where is sine equal to 1?
90.
At 90, and I'm not anywhere near 90. I'm at 0, right? So right here, I am totally fine. This is a continuous function. It's kind of like a rational function in that like a parabola over a sine curve. Sine curves are continuous. Parabolas are continuous. So the only thing you have to worry about is maybe where it's undefined, but it was never undefined there. So you're talking about a continuous section of graph. You're somewhere in the middle of that. You got an answer. You're good. Ironically, that is probably, I'm glad you brought it up. It's probably one of the bigger mistakes because trig limits, very rarely the ones I ask on a test give you answers. So you start getting this habit of just going straight to your rules and trying to figure out what to do. And people so often, including myself, will forget to actually plug it in and see what happens first. And if you don't see what happens, you're starting to grab A's and B's and things like that. Like this is one of the more common questions that'll be missed on a test. Right. Like right, where's one? Like right here, number 20. People get so used to grabbing coefficients and seeing the A over the B. They go, oh, I just got 2 limits right here. I've got this cosine one and the 7/8, and they go 7/8 times 3/4, and they get whatever that is, 21, 30 seconds. And they get used to doing that, but the reality is that's not what I get, right? Because if I had plugged the 0 in, I would have gotten 7 times a 1 over 8 times a 1. And I would have gotten that, not this. So make sure you're always checking first and see what happens. If you get an answer, you're good.
29.
Same page?
Yes, sir.
29. Similar thing. If I plug a 0 in there, I get 2 times 0 is 0. Cosine of 0 is 1. 1 squared is 1. So I get 1 in the numerator. Plug a 0 in the bottom, I get 0 squared, which is 0. Now that tells me what? There's a VA. But with any VA, right, I'm either going in opposite directions or the same direction, right? And I'm checking from both sides here of 0, and the bottom's squared. So what does that mean? That means if I check from both sides, I'm still going to get really close to 1, positive 1 on the top. It might be 0.999 or 1.001. It'll be really, really close. On the bottom, it's going to be really close to 0, but it's going to be positive because of that. And what happens when I have a constant divided by a very tiny number? It's a huge number. So you know it's going to infinity. You already kind of knew that. But in this case, because of that, you know, wait a minute, the signs are both positive. It must be doing this. And it's rare. A lot of people get sloppy on the 1 over zeros because they go, oh, vertical asymptote, DNE. But if you see something that makes it squared on the bottom, or that makes it seems like it's squared, like, look, this is a squared. If I had a number over 0 here, I don't. I get a 0 over 0. But that's a squared factor on the bottom. Same as before when you have a VA, although that's not a VA. But if you have one, think that same way. Anybody else on anything? If I was giving you a test tomorrow, I'd have like I'd kind of pity you a little bit, but like the fact that we're going to go over more stuff today and more stuff Monday, more stuff Tuesday. I mean, minus the 9-day brain vacation, but hopefully we'll bounce back quickly.
39.
39. So again, I plug a 0 in. 0 squared is 0. 0 times 6 is 0. So I get a 0 in the numerator. And then I go to the denominator. 2 times 0 is 0. Tangent of 0 is 0. 0 squared is 0. 0 times 5 is 0. So I did get 0 over 0. 0 over 0 is not a hole. I mean, it's not an asymptote. It's a hole, right? And holes have limits unless it's a piecewise function. This is not. So what do? You try, right? It's not a rule. Your rules were if it's a trig of something x over something x, or if it's a something x over a trig of something else, x, or if it's a trig of something x over a trig of something x. Right now, I got a trig, I've got a something x squared over a trig of something x squared. So I need to break it up. So right here, if I broke this up into 2 fractions, okay, and you could leave that 5, heck, you could leave the 5 and the 6 out. So you could say, all right, I got the 6/5. That's one thing. And then I've got an x and an x and a tangent of 2x and a tangent of 2x. Y'all see that I really have that. And if you wanted to leave the 6 with the x, that's fine, or whatever. So at this point, I can take the limit of all 3 of these, because that's a rule from the first sheet of our limits. A property that we have, if we take a limit of a product, it's the same thing as taking the limit of each one and then multiplying them by together. Well, the limit of a constant is a constant. And that is now a something x over the trig of something x. So take the coefficients. Something x over the trig of something x. Take the coefficients. So at this point, I get what? 3/10 when I simplify it. Y'all with me? What else? Anybody else? Anything else? Some of you are like, I didn't do the homework, so I don't have any questions. I'm telling you, sometimes that works out, but sometimes people get
59. Sometimes people get
They do. They go home, they lose their masculinity or femininity. It just gets snatched from them and stomped out on the curb. Anyway, 59. Okay, so 59, it's probably asking you something that you don't recognize this. Let's just think. For what value for that constant k, find a value for k so that this, I didn't ask a question. Does yours say anything else?
no.
Find a value for the constant k, so
That's all it's
Okay, so it's supposed to read, how do people not tell me that? Like, I've used this sheet probably for 10 years.
Yeah,
I think
probably
this question doesn't really make any sense.
Yeah, it's supposed to be so that that is continuous. So why wouldn't it be continuous? I mean, you've got this nice trig function right here, right? And then you've got this constant, which would be a horizontal line. So if you've got this trig function and you've got this horizontal line, what's the only, and by the way, the horizontal line only shows up at one point. Where does the trig function show up?
everywhere else.
Everywhere else. That's what not equal to 0 means in math. So I have this trig function everywhere on the planet. Now, does the trig function, is it ever not continuous? Just the trig function part. Like if I had just given you f of x is that and said, is that continuous? What would you say?
Yes.
You would. I would say, no, it's not, because at x is 0, what is there? It's clearly undefined, right? And if I plug a 0 in the top, I get 0. And if I plug a 0 on the bottom, I get 0. So it sounds like there's a hole there. So this trig function, the only place it's undefined, think about it, a sine curve is never undefined, right? It just goes forever to the right. But when it's over an x, if x was 0, it would be undefined at 0. Not a VA, because the top is also 0, but a hole. So this graph actually wiggles along like this, and at 0, it's somewhere. Looks like it's at 3. If you take the limit of that at 0, what do you get? Variable limit. So it looks like it rises up to 3, and there's a hole there. So this function that I circled is not continuous. But it just so happens they gave me a piecewise function. So at 0, the function is k. Well, if this thing is going to be continuous, if f is going to be continuous, and you can write that in there because that's what it's supposed to say, find a value so that f is continuous. So what would this have to be so that the hole wasn't there and it was continuous? 3. Does that make sense? Yes?
Yeah.
I mean, think about it. Here's my sine curve part, right? Here's my graph. My sine curve, you don't know this, but I've graphed it. Look at this. But this sine curve just kind of cruises along and jumps up here. There's a hole at 3. Kind of does something like that, right? But I know there's a hole at 3 because you know that, right? I can take the limit of this as x approaches 0, and I get 0 over 0, take the coefficients. So you know there's a hole at a value of 3 right there. Well, if it's a piecewise function, what has to happen at 0? What has to happen right there so that it's continuous? I have to what? Fill in the hole. Fill it. So how would I fill in the hole? Well, at 0, that would have to be 3. So essentially what you're doing is you're just checking the rules for continuity. Does the limit exist? Whoops. Does the limit of sine of 3x over x as x approaches 0, does it exist? Right? Does the value f of 0 exist? And are they equal? You're checking continuity. What is the limit? The limit is 3. What is the value at 0? The value is k. Are they equal? They are now. Right? So if k is 3, then they're equal. All I'm doing is checking the points of continuity. Great AP question. Shows up probably every second or third year. And most of the time, probably 2 of the 3 years, it'll say, find the value of k so that that is differentiable. And differentiable will only mean that not only does it have to be continuous, but when they join together, they have to have the same slope there. So like if they joined like this, that's not the same slope. One slope, if they joined like this, that's the same slope. But if they joined perfectly so that the slope, they went perfectly into each other, so that the slopes were just the same, then it would be what we call differentiable. But we'll talk about that in the next chapter. Does that make sense? I have never not put this question on your test. Just saying. I might not this year, but I have never not in the past. It's always been on there because it's such a common AP question. Anybody else? All right, back to where we were.
Are you recording, Mr. Green?
I am, but thank you.
I'm sure you got a report. But I'll let you know.
Okay, so this says limits which require more thought than rules. So I want, again, I had some people in 7th period that were asking me, man, how we were going over the test. And I'm like, I don't understand this. Like, why didn't you just graph it? If in doubt, graph it. The rules are for when you don't have any clue about what the graph looks like. But if I know what the graph looks like if I give you a square root function, graph that puppy and just look at it. It's easy to tell what a limit is if you're looking at it, I think, because most of y'all did really well when I gave you graphing, a picture and said, what's the limit? A couple of y'all missed something, but I'm sure it was careless. Like you wrote -2 and it was -2 or something like that. But anyway, like these, guys, I know what the graphs look like. Now you may go, how on earth do you know that? Well, look, like, what does the e to the x graph look like? Like this. What does the e to the negative x graph look like? If you negate the x, you flip it over the y. So right here, if I'm graphing this thing, like just using the stuff that I know I'm going to shift it up 3, or heck, if you're bothered by the 3, do these separately. Okay, just do that. Do it separately. All right, so what is the limit of this function? Well, this function is an e to the x function. An e to the negative x function. It's doing that. So what happens as I approach infinity on this thing? What am I approaching? What is my limit? Going to 0, isn't it? It's flattening out of that asymptote. The y value there is approaching 0. What's happening as I look at the horizontal line, y equals 3? Well, the limit of a constant is what? 3 itself. So I just add these together. So that's one way of thinking about this. Let me show you another way. Another way is plug in the infinity and see if it makes sense. If I plug the infinity in there, all right, this is if I wasn't thinking about graphing. I get 52e to the negative infinity plus a 3. What's e to the negative infinity the same as? E to the positive infinity in the denominator? Right? So what does this end up? If I have a constant and I divide it by a massively big number, what is that fraction approaching? Really tiny 0, right? And 0 plus 3, again, is 3. How about this? I look at this and I think, well, what's happening? I know what a natural log looks like. I don't know what this together looks like, but I do know that a natural log looks something like this, right? Natural log function. It kind of comes up here and heads that way, but it's still moving up, but it's flattening out, right? What does the e to the function e to the x look like? Starts out flat and heads and gets huge. So what's growing faster, the top function or the bottom function as you move to the right? The bottom function so much faster, right? So if the bottom function is growing faster, this is kind of like a rational function where the higher power's on the bottom, right? Those rules for rational functions with higher powers, they were all about what's growing the fastest. Clearly, exponentials grow faster than really any other function we were talking about, but certainly faster than a log function. A log function is growing pretty slowly. It never flattens out, but it's kind of like a square root. I got to go out 100 on the square root to get to a 10. I got to go out, an e to the 10th, which is a massive number just to get to 10. I mean, so it's really, really growing fast in the bottom. This has got to be approaching a 0. How about this one? Go ahead.
Sorry, question about number 2. Did you just realize that, it's exponential on the bottom, it's got to be 0?
I would.
Okay.
Because I don't know of another function that we've talked about that grows faster than an exponential function. Now, it could be a DNE. You got to be careful about that. And it could be a DNE in a situation where like the top was oscillating in a way that was throwing the answers to positive infinity to negative infinity. Like, it's going up, it's getting small. Well, on this one, it wouldn't matter because it's going to 0. But there are certain situations where like, it looks like it's going to infinity, but when you start thinking about it, you're like, wait a minute, it's actually going to infinity and then negative infinity and then infinity and then negative infinity. I can show you one of those, although it wouldn't show up on an AP test. Because right here, because I get infinity over infinity, I could have done
Something else.
L'Hopital's rule. And if I had done L'Hopital's rule here, guess what I get? I get 1 over x on the top divided by e to the x, which is the same thing as 1 over x e to the x. And if I redid the limit of that, what happens? Huge on the bottom, 1 on the top. So right there, if you knew L'Hopital's rule, which you will, and you'll revisit limits once you learn derivatives, well, I'll start giving you L'Hopital's problems and you'll go, oh yeah, I could have done this and I didn't even have to think so much. Although I will say the thinking part is kind of smart and kind of nice and it saves time sometimes. All right, what about number 3? Now, I don't know what this graph looks like. I have no idea what a sine of 3x divided by an exponential function is. But what do I know about a sine of 3x? It doesn't have a limit. So the first way people mess this up is they go, oh, it doesn't have a limit, so DNE. And if I had just said sine of 3x as x goes to infinity, that would have been true. It does not have a limit because it oscillates between 2 fixed points and never really zones in on one, does it? But wait a minute. Talk to me about these points. What are these y values ranging from? From -1 to 0 to 1, right? As high as 1, as low as -1 on a sine curve. And when that happens from -1 to 1, those are all relatively small numbers, right? Right? So the relatively small numbers on the top, what's happening to the bottom? It's getting huge, right? 2 to the infinity is a pretty big idea. So what happens for any one of those small numbers on the top? If I put any one of those over a massive number, what am I getting no matter what that top number is?
0.
I'm getting 0. Are you seeing that? So that's going to 0. Now, this is how I could really mess with you. And I've never seen this question on an AP test, so you wouldn't have to worry about it, but we can talk about it. What if I had asked you, what is the limit as I go to infinity of 2 to the x over sine of 3x? Now what's happened? Huge on the top, right? What's happening on the bottom?
alternating from positive to negative.
It's going from positive to -1 and everywhere in between. So as I'm rotating through these values, remember, huge on the top, small on the bottom, but it's switching from small negative, going through 0 to small positive. So what's happening to your results? They're switching from positive infinity when they're positives to negative infinity where they're negatives and undefined where they're
Zero.
zeros. So literally, were you to graph this thing, you're going to see this thing go and then undefined and then undefined and undefined. So what's it doing as I go to infinity? Well, I'm not approaching one single y value, am I? I'm not even approaching one direction where I could say infinity. That would be a DNE. But I've never seen them ask that on an AP test. What about number 4? Infinity y. Because what?
Exponential on the top.
Because it's exponential on the top. Okay, what about this then? What about this?
Still.
Still, what about this?
Infinity.
What about this?
Wow. Oh, I don't know now.
Guys, let's think about it.
Now I graphed this one day. It took forever because this thing, I mean, you plug a 1 in, you get a 1.
You did it by hand.
You
right?
plug a 2 in, and it's like, right? And here's the exponentials just creeping along, right? I blew this. I don't think I went to there because I don't think the calculator can do that much. But I blew it up, and you just saw the one graph off the chart, and I kept changing the window and changing the window and changing the window, and slowly the exponential function as you move further and further out. And I mean, we had to go way out. It probably took 10 minutes. And I go way out, and eventually you saw it catch up and finally be higher. So you can trust that. There's a proof of that where it's not a proof class. We're not going to talk about it. I don't know it. But yes, that exponential function is going to outgrow this. And if you knew L'Hopital's rule, I'll go back to just this 10. L'Hopital's rule allows you to take a derivative, okay? And L'Hopital's, when you take a derivative of that, you'd get 2x times natural log of 2, which is just a constant, right? And then you'd have 10x to the 9th. And then when I redid my limit, guess what happens? It's still infinity over infinity. But as I keep doing L'Hopital's rule, 2x natural log of 2 squared over 90x to the 8th, and then you do your limit again. But you notice every time you do L'Hopital rule, what do you see about this power? It keeps decreasing. Eventually, it gets to where there's no x, and you got infinity over a constant, which you know is infinity. So you could do that, but that's a big, long way. Again, L'Hopital's rule is great when you have no other answers, but a lot of times it's better to have an idea about how it's behaving. And understanding exponential growth is faster than any other function we're dealing with, I think is a really nice thing to know. All right, AP loves these questions like number 5. They go, which of the following are true? And they give you this. They give you 3 statements, and they go, is it just this, or is it only that, or is it this and this, or none of them, or all of them? They love to do that. It's going to happen at least 3 or 4 times on your AP test.
They said they're getting rid of those on the AP line exam. Are they not doing that fall exams?
I haven't heard that.
Okay. It said that like they were, because it's asking you multiple questions within one question, that was like unfair. But
I would kind of agree with that because you could be right on 2 of the 3 fronts and still miss it, but that's our country getting soft. Anyway, to me, it's all based on percentiles and stuff, and they shift the magic number around so they have a similar number of 5s or 4s. So I don't know that it really matters in the whole scheme of things, but there is some truth to that. Like when I'm grading a question like that, I'm like, they clearly understood 2 of the 3 based on I can see the little check marks and whatever. But whatever. Right here, which of the following are true? The limit of the function exists at 4. How do you check a limit at 4? 4, and from the left and the right equation. Which is the left and the right equation? The top one represents both. I plug a 4 in there, I get 16 minus 16 is 0, over 4 minus 4 is 0, so there's a hole. I factor cancel, the x minus 4's cancel. I'm left with an x plus 4. When I redo it, I get 8. So did the limit exist? Yes, at 8. So there was a hole at 4 at a height of 8. So yes, the limit exists. Does h of 4 exist? Look, h of 4 is 8. So yeah, it existed. So the limit existed. I checked it with the top function. The value at 4 exists. Is it the same? Well, then it must be continuous. So they're checking your knowledge of continuity right there. Does the limit exist? You checked it, it did. Did the value exist? You saw that there was a value there, so it did. And those were equal, so it must be continuous. Checking the 3 points of continuity, whether you realized it or not. So it must have been all of them E. All right, this question I put on a zillion tests, yours and AP Cal. It was an old AP question or similar to it. It says the table of the function values for f of x, a table of the function values for f of x are in the table. That's very wordy. This table illustrates what? Take a look at it. What is happening here?
As x approaches 1.
Do y'all see that? 1.1, 1.01, 1.001, 1.0001. It looks like the x is getting closer to a 1. What is y doing? Well, it's becoming closer to 1 from the right. So I'm getting closer to 1 from just the right side. I'm not coming in from the left like 0.9, 0.99, 0.999, 0.999. Y'all see the difference? So I'm approaching a 1 from the left. From the right. What's y doing?
Approaching 1.
It's becoming 1. So it sounds like that the limit of the function as I approach 1 from the right is 1. Now you could argue that I'm approaching 1.1 from the what? From the left. But then I would be getting what? So for those of people that are like, well, you could be approaching, if you read it this way, I'm approaching 1.1 from the left side, right? 1.001, 1.01, 1.1, 1. Like I'm getting closer to 1 from the left. But then what would my y value be coming? 0.9. I don't see that as an option. I don't even see approaching, there's 1 from the left, but I don't see it approaching 0.9. So that only one that makes sense would be as I move this way, closer and closer to the number 1, I'm getting from the right side, I'm getting closer and closer to the value of 1 as my limit. So that's a little test. Now, the first time you see that, you're like, ugh. Hopefully the second time or third time you see it, you'll be fine. All right, this was a test question. If you were to graph the following, what do you see when I approach a value of 5? Well, if I plug a 5 in there, I get 0 over 0. But if I factor and cancel it, what happens? I get 2 over x minus 5. And when I replug the 5 in there, I get 2 over 0. What does that mean?
Vertical asymptote.
Vertical asymptote. And vertical asymptotes in the end will trump any hole that might have been there. It's just, it doesn't end up being a hole at all. That might be hard for you, but it just literally, if there's still, if it looks like there's a VA there, there won't be a hole at all. It can't have both. All right, you've seen this number 8 already once today. Let's see if we can do it again. Find a value of k so that this function will be continuous. How is a function continuous?
Limit exists, value exists, limit and value.
Okay, so the limit as you approach 0, because listen, the only, this is a line. Lines are continuous. This is a weird sine function. Sine's always continuous. X is continuous everywhere. It's a line, except maybe where it's 0 on the bottom. And this thing doesn't exist at 0. So I'm not worried about that. So all I need to make sure is that these things don't have any holes or jumps in them. So right here I go, does the limit of sine of 4x over x exist? Yes. And it would be, you get 0, 0, so 4. Does the value of that exist? F of 0. Yeah, what does f of 0 give me? 3k minus 0 plus 2. So that exists. So that existed, you got a 4. That existed when I plugged the 0 in, you got a this. So what value of k do you get? 2/3 when you solve. So you're checking continuity. And this question again is very common on an AP test. All of these are not super common, but some of them are. Right here, evaluate the limit. Well, this goes back to some of the old stuff. We can relook at that. But right here, if I'm heading to negative infinity, do you have rules for fractions? Yes. What are they all about? The bigger power, what's growing the fastest? Now, square root of an x squared, that sounds a lot like an x, except it's absolute value. And by the way, if I'm looking at fractions, it's only the highest power that's going to make any difference, right? As you move towards infinity. So I can really kind of just ignore all of that stuff and go, all right, this gives me a limit of a negative 4x over an absolute value of x. But wait a minute, what do I know about absolute value of x? Sometimes it stands like a positive x line. Sometimes it's like a negative x. When is it positive x? What two cases? When I'm heading to infinity, or what? Or when I'm approaching a number from the right. In this case, I'm heading to infinity. Actually, negative infinity. When do I go left? When I go to negative infinity, or I approach a number from the left side. Well, I'm going to negative infinity. So I'm going to use the negative x version of this. And I'm going to apply my rules. What do your rules say? Take the coefficients when the powers are the same. Negative 4 over negative 1 is 4. You are done. Over here, same kind of thinking. I'm looking at highest power, so none of that other stuff really matters. But here, a cube root of something cubed is just 5x. Well, the great thing about this is odds don't have absolute value. So here I can go, oh, same power, use the coefficients. Are y'all with me? What about number 12? You too. Anybody going to the beach? Which beach? Is everybody still going to Rosemary and Humley?
A lot of people really aren't going to the beach this year.
Why not?
Like, I don't know many people. Is there any guys? Okay.
Where y'all going?
Wait, Hilton then.
Oh, Hilton, South Carolina.
Oh, that's.
Been there once. Rosemary.
Okay, cool.
Cool. I was talking to this friend of ours. We're going to be using his beach place. And I was like, how's your company doing? This is a guy, he was one of my second, your dad knows him, I think. A guy named Judah Regenstrife. He was in your dad's track 2 group. But this guy, I was talking to him and I was like, how's your company doing? He goes, we struggled a little through COVID. We had we got, most of our high rises are, just 40% occupancy. Like he owns all these buildings in San Francisco now and LA, whatever. And I'm like, so what's the net worth of your company? He goes, about 179 million.
Oh, measly.
I'm like, what?
Dude, the
And I was like, and I said,
I
is your dad still out? He goes, no, my dad sold it to the brothers. So he has 2 other brothers. The 3 of them own this 179 million. You couldn't meet a nicer guy. He's really awesome.
Wait, does he not own it?
Yeah, he's the president. His other brother's the CEO, and the other one's the COO. But they're just 3 brothers that all love each other and all hang out and still do a lot of life together. But he has 2 beach houses. Like he's from LA, and he has places all over the world. It's a lighting company. It's called Regency Lighting. Anyway, yeah. But he goes, don't judge me. I was like, dude, I'm not. He goes, I got 2 beach places down here. And he lets his friends and his family stays for free, but he lets his friends rent these places for like $100 a night, which is nothing. It's like a 4-bedroom house in a gated community. It's like a 5-minute walk or a 2-minute. So it's not on the water. It's over in Blue Mountain. It's outside of Blue Mountain actually, but it's somewhere in that area. But anyway, it's like, yeah, we've got tons of bikes and all the chairs, everything you need there. It's just set up. $100 a night. I'm like, okay. And we're going with 3 other families. So the cost per family are 3 other couples. We're not bringing any kids. It's over. And they're all in college or working anyway. But the total cost per couple, $233 for the week. Anyway, we're going for 5 days. Anyway, number 12. But 179 million. I'm like, what?
Extra couch anywhere?
I know.
That's at like 40% capacity, so it's a.
Yeah, he owns literally like these sky rises and like that 60 stories high that have office, whatever. But COVID he owns them in all these places that are really restrictive. So all these businesses just gone out of business. So he's only running them at 40% capacity.
Well, once he gets back to.
Oh yeah.
I guess owning a skyrise is brilliant because you have to get a lot of money.
It's just a
You get
cash cow.
So many businesses in one building.
Yeah, just, yeah. Anyway, couldn't meet a nicer, more generous
No,
person.
he's
which
got
is-
a beach house in Dubai. And
Well, he also like started 2 orphanages in South America. I mean, he has all these charities.
My
Like
God.
they totally, the dad retired so that he could work with all of his charities. That's his thing now.
That's incredible.
So yeah, you couldn't meet better people. I mean, they're just super kind, generous,
Anybody's gonna be-
and like totally unsuspecting too. Like, ask your dad about Judah. His name's Judah. And when he showed up at track 2, he had like 7 earrings, tats, and like he had like 6 different colored pairs of Ray-Bans. Like he'd wear his red ones one day and his green was he's very blingy. Anyway, couldn't meet a nicer guy. Totally awesome.
Totally unselfish, but
He is totally, I mean, really, it's just gives.
that's crazy.
Anyway, what about this?
It's a hole. Does he know how to do limits though?
You plug out, probably not. You plug a 0 in, you get 0, 0. So you know there's a hole. But here's the problem.
It's like that formula.
It is the formula. There's a formula on your limit sheet that I circled down at the bottom in the middle, and I said, guys, you're just going to have to memorize this one. It is probably the single most missed question on my test because it literally, you can't do it unless you have L'Hopital's rule or you graph it. You're going to have to memorize it. And if I change it to cosine x minus 1, it's essentially the same thing. That's just like factoring a negative out. And a negative 0 is a 0. So yes, that's 0. Just make sure you have that memorized. And by the way, for those of you that are going to think like this, well, if I broke it up, if I did that, I would get 1 over 0, which is d and e, minus 1 over 0, which is d and e. And of course, when I subtract 2 things that don't exist, I have to get 0. You would have gotten very lucky getting that, but that is crap thinking. And most of the time when you subtract d and e's, you don't get an actual value. So this would be your blind, crazy luck to get that, but it doesn't work that way in
I'm
math.
just playing chess and you're playing checkers. Will you give me bonus if I write that down?
That's right. Touche.
Will you be bonus if I write that down? The D and E.
No, if you write 0, I'm going to give you credit, and I'm just going to shake my head at the crap that you were doing.
Yeah.
But
I'm
anyway,
gonna do it game.
yeah. Oh, another highly missed question is this. Oh yeah, 8 over 4 equals 2. Tap your brakes. What happens when you plug a 0 in?
8 over 0, which is D and E. Yeah.
You get 8 over 0. What does 8 over 0 mean?
Unique.
That means I have a VA. It's not squared. So that's got to be going in different directions. Got to be a D and E. Are you seeing that? What about 15? Ooh, pi over 3 over 2. Guys, stay with me. I see 15 and I see people go, oh, pi over 3 over 2. Do you have the trig function of something x over something x? No. You just have a constant. Isn't that an x in this problem? What's the limit of a constant? The constant. So you got to simplify it because you need to simplify your answers. And tangent of pi over 3 is root 3. Yeah, pi over 3 is root 3. So that part gives you a root 3, and then you just carry over the 2. But guys, don't make, those are the kinds of mistakes that mess you up. What about 19? And I don't think I'm going to test you on these this year. And the reason why is it showed up on one AP test. Do the math on this. 17% of the country got it right. It's multiple choice. Monkeys. Blind monkeys would have gotten it right 20%. It was so awful that it defeated the laws of probability. But I used to teach it a lot, and I'm just wasting time doing it. So I'm going to avoid that. What about 19? Anybody?
0.
All right, that's a homework problem.
No,
Hold on. Cosine.
Mean Girls, man. That's the Mean Girls
D
problem.
and E.
The limit does not exist. That's the problem for Mean Girls. I like to throw that in.
That's
Anyway.
the mean girls problem.
That's the Mean Girls problem. And when you plug it in, you get log of 1
Yeah, what's the mean
minus 0 over a 1 minus a 1, which is 0. So you know there's a hole, but actually right here, the limit does not exist, believe it or not. You think it's a hole, but it ends up not being. Why?
Because
Because
mean girls. So we have to memorize the 1 minus cosine thing and the mean girls problem.
I don't know that I've ever made that a problem unless it was a bonus.
Bonus.
Make it a bonus.
Bonus.
Um, Yeah, this is just more practice with other stuff. Oh, one thing I have, it was in your notes, but I didn't specifically talk about it. I actually took it off your last test, but I need you to know this terminology. A hole in AP Cal is called a removable discontinuity. I'm not quite sure why it's called removable because you can't remove it, but I guess the thinking is if it's a hole, if you like stuck your finger in the hole, it kind of makes it continuous, right? If you filled it in, it's now, so you could remove it by just sticking something in there or whatever, replacing it. But that's what they call it. So if you ever see what is a removable discontinuity, that means it's a hole. That's the word they use. A jump discontinuity means it just jumps. Remember, jumps don't go to an open circle, up and back. Holes that have points above and below are not considered jumps. Those are still considered removable discontinuities or holes. Jumps are when you, along the same X value, hop up to a new Y value and then continue. Okay? And infinite discontinuities, that's what they talk about when they talk about vertical asymptotes occurring. So if you ever have a vertical asymptote, we know it's discontinuous there or not continuous there, but that is called a infinite discontinuity. So that, just know those terminologies. I will ask you that on the test because that will show up on the AP test, and I want you to be fairly familiar with it. Your AP teacher next year should go over that with you. Y'all with me?
Relative.
Right.
So,
Did I give you the third assignment sheet?
Yes.
Just stick with that.
That's what you said.
And by the way, if I have something listed for classwork, I would, if it were me, I would do everything that's on that sheet. Everything on that sheet, I would do it. Now, if you're the guys like, I make 97s on every test, then probably what you're doing is working. But if you're not that guy, or you struggled on the first limits test, I would do every single problem that's on that sheet and check and correct and whatever. And remember, we still have 2 days to talk about this when we get back. All right. All right. And y'all have an enjoyable break.
Only sizes they had were 10 and a half and
I will.
15. You know, they made 15.
Should've got 15.
But they were Hey Luke, make sure that I am maximally awake when I'm driving. Leave your boat.